Good morning, everyone. There are only 66 people in the meeting, but I'm gonna start. Okay, so today we are going to start with NFA. Now, last week we did DFAs, deterministic finite automatas. Today we are going to discuss about non-deterministic finite automata. Okay. Right. So the difference between a DFA and an NFA is if you're starting from a state, let's say you're starting from a state Q1, okay, you can go to another state Q2 when you see an input symbol A in a DFA. Okay. And the other thing is, upon seeing the same symbol A, you cannot go to another state in a DFA. This is not possible in a DFA. Okay. One input symbol only takes you to one state, that is called determinism. Okay. But in a NFA, what happens is you can go from Q1 to a set of states Q2, Q3, Q4 upon seeing the same symbol A. Okay, this is the non-determinism in an NFA. Okay, so even though in a DFA we say delta takes us to, delta is a function between Q cross sigma to Q. In an NFA, this is different because we have a set of states where we can go to. Okay, so that is the difference between DFA and an NFA. So an NFA is defined by the same tuple, the one that we discussed last week about DFAs, Q sigma delta Q naught and F. Okay, now these are the same in an NFA as well. So those four parameters are the same in a DFA and an NFA. However, like I mentioned before, the delta changes. Delta is different in an NFA compared to a DFA. Now let's see how we can define delta in an NFA using an example. Okay, I'm not going to define it right away. I'm going to use an example to show how we can define it. So let's say we have to construct an NFA to accept the language where all the strings start with A. Okay, all strings start with A, and NFA for this, by the way, the alphabet is AB. So how will my NFA look like? I have a state A, which is my initial state. Okay, now let's make this end with A. That's easy, end with A. Okay, so in the very beginning I can have any number of A's and B's. Okay, so I'm going to recurse it there. Finally, upon seeing the last A, I need to go to my final state B. Okay, now this is a simple NFA to represent this particular language. Okay, now as you can see, this is not a DFA because we have not defined all the transitions on each input symbol for all the states. At the same time, the same symbol A, simple A, takes us to multiple states when we are at state capital A. Yeah, so this is an NFA, not a DFA. Okay, if we take state A, upon seeing simple A, I can go to state A. At the same time, I can go to state B as well, according to the NFA, according to what I've drawn, the finite automata. Yeah, this is the non-determinism in the NFA. Okay, and now let's take a string AB and let's see if this string is accepted by this language. Okay, string AB. So I started A. Upon seeing simple A, I go to state A, or I can go to state B. Yeah, there are two ways, so I can reach any one of them. Then, upon seeing simple B, state A vallinnakotta, when I see state simple B, I am still at A. While when I'm at simple B, sorry, when I'm at capital B, Simple B with that comma, I have nowhere to go. That is not defined. Yeah, that transition is not defined. What will happen at state B upon seeing simple B is not defined. This is called a dead configuration in an NFA. Dead configuration or something, some transition which is not defined. So in an NFA, you don't need to have a transition defined on each input symbol for all the states. Okay, there will be transitions which are not defined. Those are called dead configurations, right? So now, is AB accepted or not? Now, under DFS, we discussed that for a string to be accepted, we have to go from the initial state to the final state in a DFA, okay? In an NFA, since we can go to multiple states, there's a possibility of going to multiple states upon seeing a particular alphabet symbol. Yeah, because of that, any one of these set could be the final state. Yeah, A could be the final state or B could be the final state. In this case, B is the final state. Okay, so here, how do I define string acceptance? I say upon scanning the entire string, I will go from initial state to a final state from the set of states I reach. Okay, if I'm going to reach state A, B, C upon scanning the entire string, then if B is the final state, then from this entire set of states that I reached, I have reached the final state. Therefore, the string is accepted. Okay, there could be multiple final states as well. Even this could be a final state. However, from the set of states that I reach, if I can reach a final state, if one of the elements of that set is a final state, then that string is accepted. Therefore, this is not accepted because A is not a final state. Yeah. And here, there's no state that I reach. Therefore, this is not accepted. Okay. Upon scanning the entire string, I have not reached the final state. Okay. So with that, let's define delta. So in NFAs, we say delta is a function between Q cross sigma to 2 to the power of Q. 2 to the power of Q kila kiyanne. This is the power set of Q. Power set of Q. Okay, power set of Q means all the things that we can write from empty set to A, B, O, A, B both. Okay, I mean, if the states are only A and B, this is what the power set is. Like all the, you can include all the subsets, set of all possible subsets of Q is called the power set of Q. Okay, right. So if we define Q cross sigma, now just like we did last week, Q is AB, sigma is AB. I have AA, BA and BB. Okay, this is Q cross sigma. Then 2 to the power of Q, what is that? I can have, there'll be a situation where I don't reach anything because that's not defined. Then I can have A, B, O, A and B both. Okay, now this is a function between these two. So now what will happen upon, by looking at this NFA, let's match this. When at state A, if I see simple A, I can go to either A or B, yeah? So that goes there. Then when at A, if I see B, I can go to A. When at capital B, if I see a simple A, I don't have anywhere to go because it's not defined. Similarly, transition for simple B is also not defined. Okay, so this is how we can understand delta in NFA. Okay, so on seeing, upon seeing an alphabet symbol, I can go to one state or two states or three states or no state at all. Okay, so no, not all states will have a transition on all sigma. At the same time, some states will go to multiple other states upon seeing the same symbol in the alphabet, right? That is how we define delta in NFA. So in a DFA, delta is this, and in the other one, the delta is this. Okay, so here transition happens to only one state. There's just one state. Here, there's a subset of states that I can reach, right? Okay, now let's see an example. Let's say I want to construct an NFA for the language where all the strings start with A. If they start with A, what do? I have my initial state on a starting symbol like a A, then I can go to B. B should be the final state because the smallest string here in this language is A. A, B, so I need to accept this, like we discussed last week. And then here I can repeat any number of A's and B's, I don't care because I have already started with an A. Yeah. So this is not a DFA, okay, as you understand, but this is an NFA, okay. And say we take a string AB, is this accepted or not? When I take A, I can go to B, still I'm at B. So I have reached the final state, therefore this is accepted, okay. And again, A වලට B ආවොතින් there's no state defined, that is called a dead configuration. Okay, and by the way, when I think of dead configurations with respect to DFAs, I can see an equivalence between dead configurations in an NFA with trap states in DFAs. Okay, in a DFA, then make it up a DFA එක ඇන්දොත් කොහොමද වෙන්නේ? This is my starting state. Upon seeing A, I go to B. Final state, I should accept any number of A's or B's there. But then to B thing, if I start with a B, I should send them to a trap state, yeah? I should send them to a trap state because anybody who's starting with B are not accepted. එතකොට දැන් මෙතන වෙලා තියෙන්නේ මෙන්න මේ trap කෑල්ල අපි අඳින්නේ නැහැ. In an NFA, this trap part is not drawn. ඒ කෑල්ල ඕනේ නැහැ. Rather, it is defined to be a dead state. Sorry, a dead configuration, okay? So trap state in a DFA is similar to a dead configuration in a NFA, okay? I hope that's clear. Right, now let's see a quick few examples. Let's take a language where the strings contain, we accept strings that contain A. Okay, strings that contain A. This is my initial state. Contain A ne A vitarak accept okay, now that is accepted. So in the very beginning, I can have any number of A's and B's. At the end also, I can have any number of A's and B's. I don't care because I have already captured the state, the situation where I have an A. Me containing A කියන එක මෙතනින් capture වෙලා තියෙනවා. Right, next one. Strings that start with AB. Start with A, B both, okay? So this is my initial state. I need to have an A, then I need to have a B. Okay, now when I'm at this particular state, I have gotten an A and also a B. So I am safe. Thereafter, sorry, not thereafter, I can do it in the same state itself. Once I have gotten an A and a B, I can make this the final state, and there I can repeat a number of A's or B's because I have already taken A and a B. After that, I don't care what happens. Okay. Next one, let's see strings that